Hi, this is Jim York from Carl Zeiss at Elliott Machinery in Oakville, Ontario. This is the first video of a series of 15 on our top habits for successful use of Calypso. One of the main things that new users of Calypso often forget to do is correct nominal values, especially on manually measured geometry. So today I'm going to measure some geometry, we're going to make an alignment system, and I'm going to show you the key items that you want to look for in order to correct your measurements to get an optimal result for your Calypso inspection. So let's go measure some features right now. I'm going to start with some alignment features here, and this is our normal training block that we use for all of our training classes. And as you see on the Calypso screen, it's starting to guess the geometry type that I'm inspecting. Now the nominal values that you see here, those are relative to the machine zero. They're not important for us to worry about yet. Once we make it to the alignment, that's when we really have to start thinking about what's going on. Remember the trick of you can change your probe stylus directly from your hand box, so you don't have to go back to your computer screen all the time. That'll do for our alignment. Let's prepare the alignment right now and take a first look at our nominal values. Create a base alignment system. So here's our top face, side face, and our other side face. Now if we take a look at our features, we saw plane 1 earlier was relative to the machine zero. But now you can see the values have changed. The X value and the Y value here actually show us the corner of the plane. And this corner that you see here is illustrated by the small trihedron. There's no need to change the X and the Y value of this plane. This simply is a representation of where I measured the plane during my manual inspection phase. What's important here is the Z nominal is now 0 because that's where we place the origin, and our A1 and A2 angles are also 0 relative to the Z axes. If I take a look at plane number 2, there are some things that are definitely of concern. This face is meant to be the Y0, the Y origin. But as you see here, the value is actually just a little over 10 microns. Naturally, this is supposed to be 0. So let's edit that. But why wasn't it 0? Why did it have a value that was incorrect? That's because this face is not perfectly square to plane number 1. So this was the average value of our plane rather than the desired value. Part of this is caused by the angle that we see here. These angles are measured in decimal degrees. They should also both be 0 because our feature is meant to be perpendicular to the top face and it's pointing in the -y direction. On our third datum face here, we can see it's a similar issue. The X value here is supposed to be 0, but it's not. And our A1 and A2 angles are both slightly different. Okay. What's the benefit of changing these values, though? Well, the first key item for us is that Calypso now can target exactly the right place. When it's driving the probe to these faces, it now has the exact perfect vector to approach the face on. Furthermore, when we're doing things like constructions, it will use those nominal values to influence the nominal values for our constructed items. And the third, and I feel one of the most important things, is that when we're creating characteristics, it's going to be able to use the correct references, and that means less editing of characteristics for us later. A little bit of work on the features can save us a lot of work on the reporting. Let's measure a few other items on the part right now so we can see how they will be affected from different special circumstances. Everyone measures a circle every now and again. Circles are a special instance in correcting your nominal values. There's something different about circles that makes them unique. If we open up with the circle that we've just created, we have our nominal XYZ locations, our nominal diameter. I happen to know, for instance, that the diameter here is exactly 12.1. The X and Y values and the Z value should be corrected according to your drawing. But that's not what I wanted to talk about on a circle. The key item for the circle is the A1 and the A2 value. Notice that they are exactly 0. They didn't require any corrections at all. This is because a circle is a 2D element and will automatically snap itself to the closest available space axes. This is important to note because it does mean less editing for a circle. But if you are inspecting a diameter and you're concerned about it being crooked or tapered, a circle is going to snap directly to the axes and you might miss important information. That's why when I'm checking a bore, whenever possible, I measure a cylinder. Let's measure the same feature as a cylinder. There. This is the exact same geometry but measured as a cylinder. What we'll see here, of course, is the diameter. Well, we can fix that. The difference between the circle and the cylinder's diameter was very, very small. But what's really important here is this. Our cylinder is not square to the top face. It's supposed to be, and therefore we'll change the values here both to 0. But the fact is that it is literally not perpendicular to our datum plane. When we're calculating things like position requires that we check at the top and the bottom of the cylinder in order to determine things like the angle relative to the top face. If you measure a circle, you're missing this information. It doesn't seem like a lot, but on a longer bore, this could have an influence on whether or not your part will assemble when calculating position. That's why it's important to not only measure a cylinder for most of the time, but to make sure that these A1 and A2 values are nominally 0 when on a plane like this. It will make your calculation of true positions much easier. Now I'm going to measure a plane on an angle.
Jason Shelter, line 1, please. Jason Shelter, line 1.
In this particular case, the key item that we're correcting is the A1 and A2 angle, except this time these values are not 0. In some other software, these angles would be calculated with an IJK value. Then you would have to do a whole bunch of trigonometry to figure out exactly what to put here. Calypso makes this easy. This is a 40-degree face. Not quite 40 degrees actually, but it's supposed to be. You simply change this angle to 40 and the other angle to 0. This is because towards the y-axis, towards the front and back of the part, there's no tilt at all. Now when I'm calculating things like the angle between these surfaces, the nominal will be absolutely correct. This is the first habit that you should be learning when you are creating your very own Calypso programs. It's a simple and easy step that will result in better measurements and an easier time editing your programs. We hope that you'll join us again for the second habit coming soon to our channel on YouTube.